So guys, very welcome and delighted to have you here, and we're delighted to be or to have moved where there is no engineer finals into the online space, into Zoom, and thank you for working with us, and delighted to have all our participants today. All the students will be presenting. So I'm going to pass over now to Liam, one of the directors of EWB. He's just going to give a short welcome, and then we'll introduce you to the judges, and then we'll start off. So Liam, over to you.
Thanks, Emma, and good morning. This is another broadcast to the ether. I feel like someone on the space station these days talking into mics. But welcome to what's now the 6th national finals of Where There Is No Engineer. And we've held previous ones in Smock Alley, in the Radisson Hotel one year, in St. Lawrence's Church. This year we come from our front rooms, our bedrooms, our kitchens, wherever you are. So welcome to all. But kind of topical, because what we're talking about this morning is designing for some of the communities that really face these kind of challenges every day. And so all of you have been getting your heads around that over the year. So today is really about showcasing the best of the projects. And we're delighted to have a series of judges here this morning who are going to interact with you over the morning. Maybe I'll let Emma introduce the judges, and just to say to everyone, well done. And good luck this morning, and we'll touch base with you later in the morning. So Emma, if you want to maybe briefly introduce the judges. Yeah,
so Andrew is our first panelist that we'll start off with, works at Rowan O'Donovan as a bridge engineer, construction engineer. So maybe Andrew, if you want to say a couple of words there to the guys to introduce yourself and your background there. Oh, Andrew is on mute at the moment.
How about now?
Yeah.
There we go.
There we are.
Yeah, morning guys. Yeah, best of luck to everybody. As Emma said, yeah, I'm a senior engineer with Rowan and O'Donovan Consulting Engineers, and have been involved with EWB for a few years at this stage. So yeah, kind of look forward to this every year. A few winners have turned out to be particularly successful really in pursuing a few things as a result of this. So looking forward to see what happens as a result of today.
Thanks very much, Andrew. So now over to Aveen. Aveen is on the committee, actually likewise as is Andrew, of EWB, and she works as consultant with Senior Analytics Consulting and has a background in environmental engineering. So Aveen, over to you to say a few words.
Morning everyone, nice to virtually see you all. Looking forward to this. I was a judge on the panel last year as well. So I'm a senior associate with Future Analytics Consulting. As Emma mentioned, background kind of environmental sustainability and resilience, and I've worked overseas quite a bit as well. So yeah, really looking forward to this, and best of luck to everyone with their presentations.
Thanks, Aveen. So Declan, our next panelist, is Director of EWB and Project Director at Varming Consulting Engineers. Declan's also Director of the Irish Green Building Council, and so he's been working with EWB for as long as really EWB has been active here in Ireland, really, like Liam, one of the stalwarts,
long time, yeah.
And judging for a long time as well. So yeah, if you just want to say a few words there, Declan, over to you.
Good morning, everyone. I just want to say, given all the disruptions this year, it's fantastic to see everyone getting through to the finals, and we really appreciate you all putting in such an effort over the year. As Andrew said, there's been some fantastic projects over the years, and having reviewed the submissions, it's no different this year. So really wish you all the best of luck today.
Thanks, Declan. So next up then is Olivia. So Olivia is, as some of you will know, a former winner of the Where There Is No Engineer competition for her Tide Toolkit 2 years ago. She's a service designer currently working in London, and is a graduate of TU Dublin Product Design. So Olivia, if you just want to say a few words there, over to you.
Yeah, so previous winner, have know the experience of where you guys are all right now and how you feel and stuff. So yeah, background in product design, work in service design. Very interested just in the whole space of community resilience. So really looking forward to see what you guys have to bring today, and best of luck with it.
Thanks, Olivia. And last but certainly not least is Bryn Moore, who's joining us from Field Ready. Bryn's technical lead at Field Ready, and they're one of our innovation partners who we worked on recently for the rapid design response, designing PPE products for developing countries, low-income countries, in the response to COVID. So Bryn, if you want to say a few words there and introduce yourself, over to you.
Yeah, thanks for having me. Yeah, as Emma said, I'm Global Technical Lead for Field Ready, currently based in Cardiff in Wales, but normally going around different developing countries, spent a long time in Nepal, recently South Pacific. My background is as a design engineer, and Field Ready's focus is really to solve the problem with humanitarian supply bottlenecks by encouraging local manufacture. So yes, thanks for having me, and good luck with your presentations. Cheers.
Thanks very much, Bryn. Excellent. So guys, we'll get started then. Our first project is Flyco. So Liam is going to be discussing his team's project, which is on black soldier fly farming and its implementation and adaptation to Zambian agricultural life. So Liam, I'll make you panelist there. Just 1 second. Liam Connor. Sorry, I'm missing to get into it. Okay. So.
How you doing?
Hey, Liam.
Is that coming through there?
We can hear you. We just can't see you quite yet, but hopefully that should be coming through.
There we go.
Yeah, excellent.
Thanks.
Great. Yeah, good to see you.
Okay. So will I just start?
Yeah, if you want to share your screen there. Yeah, I've enabled all panelists to share screen, so it should work fine for you, hopefully. Yeah, excellent.
There we go. Okay, how you doing, ladies and gentlemen? My name, as we said, is Liam Cotter, and I'm from TU Dublin. And today I'm here to talk to you about black soldier fly farming and its implementation in rural Zambian communities. So quickly, just a glance through the team. As I said, my name is Liam Cotter. With me on the team today is Brian Richards, Emer Moore, and Sean Flanagan. So what is the problem? Food security in rural Zambia at the moment can be a serious problem, with a large portion of the population having an over-reliance on single cereals such as maize or on their livestock. This leaves them very vulnerable in times of drought or disease. 80% of Zambia's poor work in the agricultural sector, which again singles out the rural communities as being most heavily affected by drought and disease in times of famine. Malnutrition is the least addressed public health problem in Zambia, with 40% of the population suffering stunted growth and 9% of children having a birth weight less than 2.5 kilograms. So what can we at Flyco offer these people? We hope to improve the quality of their diets and their animals' diets through the use of efficient farms that make use of waste in a sustainable way using local materials. So the black soldier fly itself is native to Zambia and thrives in warmer climates. As a fully grown pupa, it can be composed of up to 60% protein, and this high protein content coupled with their rapid growth rate make them an ideal food for larvae and humans. As an adult fly, the fly has no mouth and thus cannot transmit diseases. An adult fly can lay 400 to 800 eggs, and each of these eggs can grow into a larvae which is capable of consuming 200 milligrams of compost every day. And crucially, this farm can be left to self-sustain, leaving the farmer or businessman free to have their day on other ventures. So this is our design. It's based around a standard blue barrel and produces a protein-rich food. It can be used to teach younger generations responsibility for looking after aspects of farm life. It's easy to clean, only has 2 removable parts inside the barrel. It's easy to assemble using local materials, and the design was made in such a way that if specific aspects of design are not available to you, you can readily substitute them for anything that you have. It's reusable and semi-self-sustaining, and it is scalable for local entrepreneurship. So just a quick look at the diagram on the right-hand side. You can see at the bottom half of the barrel is a leachate, which is a fertilizer. It's rich in nutrients, and this comes just from runoff from the compost above. The compost above is where the larvae will actually live and feed, and the ramp on the right-hand side is how they exit the barrel into the collection box once they're fully grown. So how does it actually work? So when you have your farm set up and built, you remove the lid and ensure that the inside is clean and sturdy and ready to begin farming. You then add your edible material, which is anything from household waste, farm waste, it can even be animal feces. You then add your black soldier fly eggs, replace the lid so that they have darkness, which is how they like to live, for 18 days, regularly checking to add more food or if it needs to be cleaned out. Then after 18 days, your larvae are fully grown, and their natural instinct is to leave their current habitat, which the only exit is out through a ramp, which leads them into the collection box. You can then collect your fully grown pupa, you can drain your fertilizer spray, and you can replenish your compost and begin the cycle again. So here is the booklet which we hope to distribute within communities in Zambia. It teaches how to maintain the farm and can be printed locally. It shows the potential of this farm to be expanded to create business opportunities, and not only for your family or to make money for your community as well. It demonstrates the construction of the product. It shows that it's cheap to the booklet is cheap to manufacture and can be displayed in a public setting, as it can be folded out into an A2 poster. We hope that these will then be displayed in places such as community centres to help spread the word and provide this information in an accessible way to locals. So what opportunities can our design provide for Zambia? It uses the community's biological waste and creates many outputs of great value from what was previously waste in landfills and within the community. It can be taught within the community to create jobs. This can be expanded and scaled up for local entrepreneurs. It reduces the reliance on foods such as maize and livestock, which can be affected by drought and disease. It expands farmers' opportunities to feed livestock with more diverse food source, and can teach entrepreneurship through the production of flies and open doors to those who maybe mightn't have realized that this could have been a sustainable way to live. So just a quick comparison of the black soldier fly larvae to other traditional foodstuffs such as beef burger and chicken fillet. You can see across the board from 100-gram samples in protein, calories, and fat content, the black soldier fly larvae is streaks ahead, especially in calories, where a 100-gram sample can provide up as much as 615 calories, as opposed to only 165 calories of a similar sized chicken fillet. And within this 100-gram sample, 73 grams of this are composed of fat and protein, which has all come from the use of household waste. We hope to use these, or we hope that through the implementation of these farms in rural Zambia, we can create healthier people and animals and help improve the livelihood of rural Zambian communities. Thank you very much. And if you have any questions, I'd be happy to answer them.
Okay, excellent. Thanks very much, Ian. That was really interesting. I'm just going to get your team colleagues there as panelists as well. So we got Brian Richards. And then Emer. And Sean Flanagan. Yeah.
Hey.
Great. Okay, so over to our judging panel. Any first questions or comments from you guys?
Just well, two sort of related questions. First of all, well done on the presentation. It was very, very comprehensive, very, very good. And it obviously has a lot of potential. I was wondering, is there this type of farming in Zambia at the moment? Is it rare? Is it common?
Specifically, black soldier fly farming isn't particularly common, but there are cases, say, in the country and within Europe as well, where it's beginning to be seen as an alternative food source. So it is something that has been proven to work maybe just not necessarily in these rural communities just yet.
Okay, and if, say, compared to existing systems, you obviously did your research on this. What sets your product apart from existing farm systems?
I suppose the existing farms that I've seen anyway are currently more on an industrial scale. The
Okay.
design and the value here is that you can take what you already have and kind of just reorient it into something that you can make work for you. So these blue barrels, they're basically universal across the world now. They don't have much of a use apart from holding liquid, but now they can provide you and your family and your livestock with really, really high protein food.
Yeah. So yeah, I can see the benefit of that, and obviously the fact you have your booklet with it as well is very useful. So that's my only question. Well done again.
Thanks very much.
Yeah, I've got one or two queries as well there, guys. I can see from the presentation, which looks particularly good, that you've actually built a prototype of this guy. You haven't managed to source any black soldier fly, have you guys, to test this thing out yet?
Sorry, can you hear me? We were going to start using black soldier fly with the barrel. We did actually source some black soldier flies from like reptile stores. They use it quite a lot because of the high protein content.
Oh yeah.
So we were going to start. It was just actually the lockdown and the timing. The kind of prototype got left. We got left in the college, but we did have plans to start. We had plans to. We had a location which was going to be in beside a. It was supposed to be beside a greenhouse in Wexford where we were going to start doing it and just testing like how to use it and stuff like that to kind of more streamline the process as well.
Oh yeah, and are they let's say common across Zambia, the black soldier fly, as in
yeah,
you wouldn't have too much hassle, quote unquote, sourcing them in Zambia?
No, they're actually that was actually going back just to add on to Liam's point. The black soldier fly is actually found from all the way from South Africa all the way up to I think Ethiopia. With just to add on to Liam's point, there is like farms set up in countries such as Ghana as well. They're able to who are utilizing black soldier flies at an industrial level. So it wouldn't be that difficult to find like a resource for black soldier fly larvae.
Yeah. Okay, that's all I have for the moment anyway.
Thanks, Andy.
Yeah, I've one or two questions. So how much, you kind of referred to kind of the 100 gram equivalent in comparison to beef and so on. I suppose what quantum of larvae would you expect typically, I don't know, on a say a weekly basis or a daily basis from something, from a single blue barrel maybe?
So each larvae, kind of just going to the numbers of it, from an egg, it goes from 0.002 grams to 0.1 grams in 16 days. So if you have 18 or 800, say, eggs from one fly, you might expect to have a couple of thousand eggs in the barrel, which would give you, say if that's replacing every, say, you could get a couple of kilograms every 16 days from one barrel. And then depending on how many barrels, that obviously could be scaled up or down.
Okay, yeah, that's useful to know. And have you come across any information in terms of, I know it's a big one at the minute, the kind of bioaccumulation of say microplastics in fish. Is there any potential if you're using say the human waste or the animal waste for any kind of bioaccumulation if this is being used as a food source?
I'm not 100% sure on that, so I couldn't really give an answer, sorry.
Yeah, no, that's fine. It's just kind of something else to maybe think about in the background when you do use kind of other wastes.
Definitely.
No, but brilliant presentation. Well done.
Thanks very much.
I have a couple questions as well. So the booklet's really good. I think it's a nice way of kind of like complementing the prototype and the whole thing itself. But just wondering, like how would you expect people to integrate this into a community? So you're saying it works on an industrial level, but I'm just wondering, like, this shows you how to set it up, and it might give some nutritional information, but I guess, like, how would you plan to address kind of the cultural change for people adopting a new food source, and have you considered that at all?
I suppose, well, there are cases in Zambia currently where insects are eaten. So for human consumption, it mightn't be as massive a jump as it would be, say, in Ireland to try and incorporate this into their diet. But also, I suppose we try through representatives, maybe one-on-ones with people in the community, to try and spread the word of how it can benefit their livestock, and then just hope that once it's picked up in one area, that then they, through just kind of word of mouth, will help spread that to their neighbors and their community and then neighboring communities.
Yeah, okay.
So I suppose, yeah, that would be my main hope.
And just wondering as well, like, in your research of kind of looking into the larvae and everything in its life cycles, did you come across any kind of adverse effects that could come out of this, like almost over farming and having like a colony of flies that you can't then manage? Or did you come up again, like, did any sort of adverse effects like that come out of the research?
They didn't necessarily come up too much because, as I said, like the flies, when they're an adult, they don't live for very long and they can't eat. So there's not a lot of damage they can really do. Like if, say, if there was a fly bloom or whatever and you ended up with too many, then I suppose it could lead to a growth in the population of these flies in your area, but it's not going to necessarily damage you or your crops immediately. So it's reasonably safe, I think.
Yeah,
cool.
Just to add on to what Liam was saying, like during the process, we were actually just stopping them before they actually turn to a fly. So you're kind of intervening in the process of them basically just turning into a fly. So you can kind of control it that way as well, to kind of like overstock the population of flies flying around. Yeah.
Cool. And just one more question. I guess, like, what next? What would you do, like, after today and kind of maybe post-COVID? Where would you like to see this go?
So our very next step, I would think, was to actually set one of these up, as Brian was saying, in a greenhouse, stock it with eggs and see at what temperatures will they grow up to their required size, or how quickly will they actually grow? How does the system actually work when it's in use rather than just on paper? So I suppose our next step would be to build a full working model.
Yeah, and also we're planning to work on the booklet as well, just because we know that in Zambia, English is kind of widely used in education, commerce, and kind of law as well. But like there's also 74 languages available in Zambia. So we kind of want to, especially with the booklet, make everything more visual and more comprehensive visually, and kind of break the language barrier between different cultures. So everyone kind of has that, depending on like which part of Zambia you're in, if you're in kind of a rural part, or even if you wanted to set up a small one in like a garden in a city, it'll be accessible to you. So
yeah, I also think we should like add the fact that there's an entrepreneur opportunity inside the booklet, and kind of giving more information into how you can develop this into a business as well.
Yeah.
Great, thanks.
Thanks very much.
I just had a quick one. I was wondering if you did any analysis into the current markets. Where do Zambians currently get their feed from and fertilizer? I mean, is it all imported, or is it made locally? Just sometimes to be aware whether by introducing something you don't upset existing markets that may put people out of jobs and things like that. I was just wondering if you'd looked into that at all.
So as far as I'm aware, a lot of the feed that's used in smaller rural communities isn't bought in, it's grown in the community. I'm not 100% sure what industries this could end up upsetting. As you were saying, that is something that we definitely need to look into further. But I'm reasonably confident that it's would be a benefit to the community as a whole, and not kind of take away more money from the community than it's giving back.
Great, yeah, I love it. It's I love the fact that it's using really simple local materials, and the booklet looks great. So yeah,
Thanks very much.
Yeah,
Thank you.
brilliant.
Excellent. Any last questions from the judging panel there, or covered it all off?
I have
Nope.
one more. Just
Yeah,
wondering,
absolutely.
did any of you guys actually eat any of them?
No, not yet.
I was gonna, but we just never got time to. When we were in the reptile shop, I was gonna start eating one. They're not slimy. They're really dry. So and we talked to people over in kind of the food development lab over in TIT or TU Dublin Colbrew Street, and they were kind of going through as well, like the cooking process or like how to kind of eat them more of a gourmet level. But yeah, we never got the chance to. But it wouldn't be a thing I'd say no to.
Thanks.
Well, that's an adventure to look forward to then after COVID today. We'll see. we'll keep in touch. We'll have a little gourmet dinner together. Excellent. Well, look, thanks a million, guys. And if there's no more questions there, we'll move on. Yeah. So Liam, if you'd be able to just stop screen sharing then at the moment, thanks. And then I'll make you guys attendees again. Thanks very much. Now, so starting. Sorry about this slide today. Where are you going? Sorry, Jesus, yeah, I'm going to place them together. Okay, excellent. Okay, so we're going to move on now to our, sure, I'm not on mute, no, I'm not, excellent. Move on now to our second project, which is going to us from Trinity Engineering, Water Maze. So David is going to be presenting his team's project, Water Maze, which is a system that builds on solar water disinfection technology that aims to enable rural communities to manage the disinfection of their water supply. So I will make David presenter now.
Hello, everyone.
Hi, David.
You guys can hear me fine?
Yeah.
Yeah.
Absolutely. Can indeed.
Beautiful.
Yeah.
Okay. Perfect. You can see the screen? Everything works fine?
Yeah, we can indeed.
Perfect.
Yeah. Thanks, Serge.
So first of all, thank you for having us. I will start by saying that up to hundreds of thousands of people die every year due to unclean and unsafe water. We are proposing a solution, Water Maze. We looked specifically at Zambia, but the trends are similar in other low-income countries. After several conversations with Keith Brown, a high school teacher that has been heavily involved in helping rural villages in the western province of Zambia, we understood how much a lack of clean water is a major issue. The women in villages have to boil water to sanitize it, and this means spending countless hours to do so and being exposed to air pollution. If we look at the past 10 years, lack of water, sanitation, and hygiene has stayed as the third highest risk factor for death and disability in Zambia. Moreover, in 2018, the third and fourth highest cause of death were lower respiratory infect and diarrheal diseases. In terms of disease, it's easy to see how high it is. Cholera alone can kill thousands of people worldwide, and this cripples rural communities, really. And as I mentioned before, the way that rural communities deal with this is by boiling water.
but this puts the women in close proximity to soot and smoke, which can lead to respiratory infection and diseases. So how does water maze work? We took in consideration some factors such as the high sun exposure and low electrification of rural Zambia. It came up with a system that works solely on sunlight. Here's a video looking into the system. Everything starts with an inlet tube bringing available water to water maze and an outlet tube taking the purified water to a storage water tank. The inlet pipe can leak water maze directly to a water reservoir, such as a dammed section of a river, or alternatively, a water tank can be placed to feed the contaminated water into the system. Regardless of how the unsafe water gets there, a physical filter will prevent particulates from reaching the channels of water maze, both decreasing the turbidity and simplifying the maintenance of the system. The channels of water maze are covered by a transparent plane that lets the UV rays of the sun through. Here is shown the path the water would take. Every green zone is a bisection of the channel, creating an almost fractal design that maximizes water purification per unit area. Here we can see an animation of how water packets would travel through the channels of water maze. As the water travels through the channels, the UV present in sunlight damages the pathogen's DNA, inactivating the organisms. Moreover, water maze is below the water level of the inlet and outlet. This means that the channels are always filled with water. Therefore, there is no open channel flow in the system, which would interfere with the consistency of the disinfection. Lastly, the clean and safe water is stored in a water tank where the people can access it easily through a tap. Water maze is the result of several iterative designs, which led us to optimize costs, efficiency, and simplicity. Moreover, it is completely scalable. You can install parallel installations depending on the local needs. As I mentioned, women are mostly in charge to clean water. Therefore, we wanted a solution that empowers them. The idea is to create a water committee represented by women that is taught how the system operates and how to repair it. They could also collect a small tariff to offset possible maintenance and ensure local involvement in the project, something that is vital for the long-term success of any system. So what's next? Well, first of all, of course, as I suppose with many others, COVID-19 put us a bit of an delay, but we intend to start biological tests on a 3D prototype of the system. We also managed to contact Dr. Sgobba, a materials engineer at CERN, to evaluate different material options. And we concluded that for the top plane, it would be beneficial to carry out weathering tests for analyzing the aging curve of different polymers and glasses. For the channel, instead, the most captivating option seems to be stainless steel 316L, as it's very durable and doesn't leach contaminants in the water. It would be also interesting to see how some 3D printable materials like polycarbonate could compare. Lastly, in parallel to these tests, we want to start analyzing local integration methods and different production strategies, possibly exploring partnerships with NGOs or governmental agencies, of course, if Engineers Without Borders is okay with that. For example, the Swiss Federal Institute of Aquatic Research and Technology and the SODIS Foundation have great experience with solar water disinfection systems and how to implement them. Therefore, getting in contact with them would be a logical next step. So, to recap. One, we want to take a huge vital issue in developing countries, that is clean water. Two, we want to leverage known technology, but we significantly improve it to make it efficient and durable. And three, we want the project may have wider positive impact on both gender equality and local economic growth. Thank you very much for your attention. If you have any questions, we will gladly answer. Thank you.
Excellent, thanks very much, David. I'll get your teammates on screen there now. So, Richard. Actually, I don't see your teammate Richard. I'm not sure if he's there, but move on to the next one.
Unfortunately, some of them have jobs right now. They're working.
Okay.
Yeah.
Fair enough, absolutely. Do you know maybe who definitely is online at the moment? I'll just have a look through there. I don't see Trudy or maybe is Kian. Yeah, I don't actually see Karen O'Flynn. Okay, there's Karen O'Flynn. So.
Karen is in, I think.
Yeah, so I've just promoted her now. So I think it's maybe just the two of you from what I see. So yeah. Obviously, if someone is there that I've missed, please just make yourself known to me in the chat. But I think that's it. So yeah, guys, if you want to start off there, any first questions from the judging panel?
Oh yeah, great presentation, and yeah, it's definitely a massive problem in many places that we work. So it's good to see some good ideas on that. I was just wondering how you would ensure that the setup is maintained and cleaned and looked after, and what other risks if it does start getting blocked up or is not really, is sort of left, you know, does it just stop functioning, or does the water get less clean? I just wanted your input on that.
Yes, okay. So the system, the plane that will be put on top can be removed. It will be clamped on the system, so it can be removed. So once you remove that, there's just channels which you can sweep through, you can clean easily if there is any debris left. The idea to have a filter at the start of the chain really is to prevent, you know, the particulates of like dirt to come in and clog the channels. But of course, in case it happens, it is a cleanable system. It is maintainable. Yes, that we.
Yeah, and
have I answered your question? Sorry, is it?
Yeah. It's just I could see just one of the main challenges with this project would probably ensuring there's a culture to clean it and maintain it, because a lot of the time they would probably just divert past it as soon as it gets blocked. So that's one of the sort of insights that we get from going into
I can definitely see that. That's also kind of the idea behind creating a water committee. Since women anyways are generally in charge of cleaning the water, this would be kind of like if you create a water committee that is involved in maintaining the system for the community, then it would be I guess a way to ensure that the system stays cleaned and looked after.
And we intended on offering like a small educational program to go with it. We were planning on just dropping it into the community and abandoning it. We were hoping to leave kind of like pictured guides and things they could follow along even once we're gone.
Exactly.
Yeah, brilliant. That sounds great.
Perfect.
I just had a question about, so obviously this is intended to be manufactured externally and then brought to the community. How have you looked into the ease of manufacture and the cost of manufacture? So would it be financially viable?
We've not looked specifically at the cost of the steel and manufacture. I mean, the welding process would be quite simple because it's a simple design. I know that steel 316L, it can be pricey, but considering how long it lasts, how durable it is, we need to kind of analyze what is the better option, because we could make this with a 3D printable material. But then, of course, if it breaks down, we do not want that, especially if we manufacture it externally. There is the option of manufacturing locally, because this steel is quite common, is one of the more common type of steels. So there would be the option, especially if we can manage, I'm not sure like the connections, but we could look into kind of having a partnership with a governmental agency that would be able to support the manufacturing process. And I mean, these are things, a very good question that we need to kind of look into once we can do material tests and kind of see what options we have for manufacturing.
Okay, yeah, no problem. And just for example, one module, you were saying like it is scalable, you can attach different modules to each other. But for example, one module by itself, how much water will that treat over a given time period?
Okay, so we used the formula done by derived by Dr. Gills, and I have the names. I mean, I put it in the document we sent, but using that formula, using conservative figures, we get 288 liters of water per hour at 99.99% disinfection.
From one module?
Yes, exactly. It is a 2x1 meter module, so it's quite large. The nice thing about this, especially like if we 3D printed, you can also change the size of the channels, or of course you can put multiple models one next to the other. So there are a lot of options depending on the local needs. On if you need less water or if you need more water, you can scale it up, no problem.
Well, thanks very much. Cheers. This is a very good presentation as well. Well done.
Thank you very much.
Excellent. Any other questions or guys in the panel?
Yeah, I just have one query. And it's been kind of partially addressed, but with regard to, obviously this is, there's quite a, I suppose, a large degree of technical input in this with regard to like sourcing materials and actually constructing it. But with regard to like educating local people, would the idea be to almost go out there, demonstrate how to build this thing and how to maintain it and provide them with information? I was just wondering how this thing is actually going to be physically implemented. Would the idea be it would be per house, or would it be, one large filtration system for a village or something like that?
Okay, very, very good question. Thank you for asking it. In terms, we don't know how the community will react. Okay, this is like a different idea. They are used to something different. So of course you need to integrate in the right way. The idea is to have a long-term system so they're not dependent on an external source. The community can take care of the system by itself. And if it breaks down, they can fix it. They don't require an external support. Because of course we will not be there forever, right? Once we implement it, the idea is that they have it for the long term. This is basically the way of integrating. It would be very productive and beneficial to go on the site and kind of see what the local needs are, because you can, as I said, this is scalable, right? So we could have one per household. We could have one for the whole community. It kind of depends then on them, on what they think is better suits them. Because I don't feel like I can make this decision now without knowing exactly how the community would react. But it definitely needs more research into it. Thank you for asking.
Okay.
Have I answered the question, sir, or did I miss something?
Yeah, this is obviously quite at an early concept stage. It's just really a question to see, obviously as you work through the concept stage, you need to kind of have an eye on how it's going to be actually physically implemented on site,
Of course, yeah.
Yeah, I would have kind of a similar themed question. I'm not sure if you presented it, but what kind of size is the module that would give the 288 liters per hour? And like in your head, where would it be located? Within a community? Is it, you're saying there's one per building? It's just to get that kind of understanding, I suppose, of that feasibility.
The 288 liter per hour version is 2 meters by 1.
Okay.
So it's not overly huge, I would say. Depending on the water source, it could be installed either like at the entrance of the community if it has to serve the whole community, or if it's per household, then you can have it, of course, in next to the house.
So I suppose, is it on the ground? Is it on a roof? Is it?
Oh, it would. It wouldn't be on a roof. It would be not on the ground, like on some pillars, basically.
Okay.
Yeah.
Great. Thank you, and thanks for the presentation.
Thank you very much.
Just a quick thought. I was thinking, if it's in the community, if you thought about any sort of anti-theft features, because obviously it'll be a kind of a block of steel that might be quite high value. Just a thought there that it might be something worth considering when you take it forward.
Yes, that is a very good question. We have not really developed any anti-theft issues at the moment. The idea, of course, if you secure it properly, it would be very hard to do so. You could build fences around the system? That's a very good question for anti-theft. If the, yeah, I guess if someone goes there and actively tries to break it and take pieces, then that is something that we need to take in consideration. Thank you.
Any last questions there, guys, from the panel?
Yeah, I don't really have a question. Just a very quick thing on the steel. Don't forget now, steel corrodes quite a bit when it's in the presence of water. So you have the additional fun of trying to, you know, add in corrosion protection. If you're just thinking about steel, you know.
Yeah.
Not really a question, more of a statement.
Absolutely, valid statement. Okay, guys. Well, thanks very much, David and Karen there. So yeah, if there's no further questions, we'll move on to our next presenter. So maybe if you can stop screen sharing there, David, and I will make you guys attendees again. Okay, excellent. So now we're going to move on to our first submission from NCAD, the National College of Art and Design. So Philip is going to present on his project Pipe Tools, which aims to enable anyone to create their own garden tools using simple and available materials. So I will make you presenter there, Philip.
Hello.
Hi, Philippe. You're very welcome. Thanks for joining us.
Okay, so I think Emma explained my project pretty well, so I think there's nothing to add on the beginning, apart that my project gives you the possibility to turn a pipe, steel or copper or brass, into a shovel that you can see on the screen. So in partnership with Where There's No Engineer, we are asked to look at Kabwe in Zambia, which is here. And we are asked to look at street kids and communities like Zamda. Like Zamda, which provide schooling and free gardens to those kids. So I decided to focus in my research on these three topics, which were phone chargers, because almost everyone in Zambia have a phone. Another two were based around growing gardens to improve and support local community gardens. And last two were designed to make science classes cheaper and more enjoyable to kids. So after presenting to tutors and Engineers Without Borders, I was suggested and I decided that it would be nice to focus on gardening tools to help schools and community gardens to improve their, to just help them, support them. So I started with milk bottles and cutting out the shape of the shovel from them, but this idea turned out not strong enough for the purpose. So I found this 20-liter water bottle and I decided to just use the same idea on it. But even after adding a bamboo stick, the shovel was like not strong enough. And another disadvantage of this design was that a bottle like this would be too valuable for people of Zambia, as it can store water instead of just, turning it into the shovel. So this is my development process of the shovels. I started with these two ideas. And after that, when first ideas didn't work, I decided to spread the tin can and fold it like an origami into shovel shape. but it would be too hard to attach any handle into that, and it was too small on the end. So I got the idea to spread the copper pipe into flat piece and fold it into origami shape, so it creates the shovel. But after these two prototypes, I decided to just cut the shovel shape into the pipe, and it gives you this beautiful piece. So this is my final design, and it's made out of steel instead of copper because copper is a soft material. It was really good for creating prototypes, but like for the gardening, it's okay, but steel would make it more future-proof. So half of the shovel is like the handle is made out of wood to save valuable material and keep the cost lower. So this is shovel making process. First, the pipe have to be cut into right size, and then it's cut diagonally. After that, we cut on the longer side till the end, and we spread the pipe with the hammer and flattening it. After that, we mark the shovel shape. It can be marked with a pencil or marker or even a nail if someone don't have it. Then we cut out the excess, we round out the corners, and we bend it to the final shape, which looks like this. So additionally, I designed a jig that would help to create the same pipe tool you've seen before. This is an example of how this jig would look like. With mass production of pipe tools, the whole idea becomes a small industry. It can be sold to, let's say, tourists, or it can be even exported outside of the country. So on the right, you can see the tool, the jig I made at home with simple tools. So it shows us that it can be easily reproduced, and and it can be spread around the community. So I think it would be nice for the first jig to add the instructions, engrave them on it to help people learn how to do it. So on the left, you can see how it would look engraved. So on the right, instructions would be placed in the crucial places to help someone to build the shovel. So on the further development of the project, I would like to focus on creating jigs for different tools, such as ones on the right, but more research would be needed to find out what tools people actually need. So this is my final product. It's 16 centimeters in length, the metal part of it. And from 1 meter pipe, you can make 6 shovels. And I couldn't find the price of the steel pipe in Zambia, but I found one in South Africa. It's around €3.20 for 1 meter pipe. And I found out that Zambia imports steel pipes from South Africa. So I think they're easily, you can get them in Zambia as well. And that's it. Thank you. And any questions?
Hi, great presentation. It looks amazing. I was just interested in how you identified the need in Zambia and whether you did any research into traditional tool making in Zambia and the history there, and also local markets, whether they actually manufacture any sort of tools in Zambia as it stands.
To be honest, not really. It was mostly based around gardens and school gardens. So this project shows us that anyone can build a shovel, and even kids in the schools can learn how to do it. It showed them that, think outside the box and simple DIY.
Thanks very much, Philippe. Really interesting presentation. Any other questions there, guys, from the panel?
My question was pretty similar, actually. You obviously put a lot of work into it, a very good presentation, but I'm wondering, is it actually solving a problem?
I think it does. It creates shovels cheaper than and more durable than plastic ones, and you can mass produce it and create the market around the whole idea. So after person gets the jig to create the shovel, but after a while he don't really need a jig. It's only created to help them start kind of the business.
Okay.
Any other questions?
Mm-hmm.
I suppose I'll ask a question. If steel isn't available, or if the steel, there's, I suppose, another purpose that the steel is being used for, is there any kind of option around alternative materials, I suppose?
I think it could be even made with, let's say, plastic pipes. But if you want to spread the plastic pipe, then it would have to be heated up to, melted kind of. It can be done with any brass, copper. The idea is still the same. It's just the process that's important.
Okay.
Any more questions, guys, in the panel, or? Nope. Okay. Very good. Well, look, thanks very much, Philippe, for your presentation. If you want to, stop screen sharing there, I'll move you back to attendee. Okay, so now we're going to have our fourth project. Jesus, sorry, I think I just made Andrew an attendee by mistake, so let's change that. There goes to show the importance of just taking your time in actions online. Sorry about that, Andrew. Now, okay, so the fourth submission is from TU Dublin, from the product design. Our second product design group coming from there. So Jennifer is going to present on her team's Project Q, which is a game that's designed to educate communities about menstrual hygiene and menstrual health management. So Jennifer, I will get in there. Jennifer, now we just can't see or hear you at the moment, just to confirm that.
Hello?
Oh, there you are. Excellent.
Working.
Hi, Jennifer. Yep.
Hi. So I'm going to talk you all through our product Q, which is a menstrual health management toolkit for schools. My name is Jennifer, and my teammates Vin and Garode will be joining us for questions after. So the problem area that we chose to focus on was menstrual health management, or MHM, in a school environment, as unfortunately many young girls' educations are affected by their period. So in Zambia, this is especially the case in rural areas and communities where information and knowledge of menstrual health is clouded with superstition and stigma. So many young girls are only taught about their periods by family members, so aunts or grandmothers, and this information is not always accurate and is often only taught upon a girl's first period. So this can create a great sense of fear in young girls, and the lack of information can often lead to girls not knowing how to take care of themselves at this time. So the lack of education and materials for young girls negatively affects their experience in the school environment, as they can feel embarrassed, stressed, or even ashamed of their period. This is further worsened by teasing from other schoolmates, especially young boys who have not also been educated on the issue. So the absence of support ultimately leads to girls choosing to stay home rather than go to school when they have their period, which results in young girls in Zambia missing an average of 10% of school days every year once they start their period. So the Zambian government has identified the need for education and support in recent years, and since 2017, they've made effort to provide girls in school with sanitary wear and to introduce MHM into the school curriculum. But as this topic is still seen as a taboo, many schools don't have the materials and resources to effectively communicate vital information to students, and we saw an opportunity to create an educational tool for exactly this purpose. So meet Q. So Q aims to address the problem by dispelling rumours, educating young people, and fighting stigmas through opening up a conversation. The game can be played by groups of both boys and girls, with each student taking turns to spin the wheel and select a category. So there's a total of 6 categories, and they vary from questions to tasks to even role play scenarios. So the product cues a conversation between students about menstrual health and helps them gain an understanding and empathy towards their classmates. So the product aims to solve the previously mentioned issues by providing accurate information and empowering young girls to take control of their own menstrual health. By creating an open and supportive environment, girls will no longer feel outcast or embarrassed by their period in school, and they'll be able to continue to learn alongside their peers. So Q is unique in its value proposition as it gives students and tools to teach themselves and to learn from others as well. The product has been designed to align with WASH and school-led total sanitation principles to ensure that the communication is effective for the school environment. It also aligns with 5 of the Sustainable Development Goals on the grounds of health, education, and equality for young girls. And the product has the potential to meet more of these goals through cardiac expansions. So now to give an overview of the product's costings and distribution. So the product consists of printed and laser cut parts, which can be manufactured locally in Zambia by businesses such as DigiPrint and Shades and Colours. The cost of manufacture is estimated to be relatively low at €7.15. And once assembled, all of the components will fit inside the games box itself and will be ready for distribution. The final product can then be distributed to schools through partnerships with Engineers Without Borders, organisations like Zambia Ireland and other NGOs. And shipping can be done internally through DHL, who also offer discounts for NGOs. So we believe that Q has the opportunity to make a difference around the discussion of menstrual health in a classroom setting. Our team comprises of product design graduates who all have great interest and previous experience working in an educational and school environment and designing for these environments. The product also offers opportunity in terms of employment for communities in Zambia, as the product can be manufactured and assembled by local businesses, as well as being distributed to numerous schools in the community. And then going forward, our future plans for the product include testing the card samples in a co-creation session with an Irish secondary school to see the students' engagements and to get their feedback on the cards and the cards content. And there's also a potential to expand the card decks beyond just menstrual health management into other topics and areas of the school curriculum. And similarly, we would be looking to make a condensed version of the game so that students can bring it home and use it with their own families and households. This would be so that the discussion doesn't just end in school, but that the information is brought home and it's spread throughout the community. So thank you so much for listening. We'd be happy to take any questions that you have.
Brilliant, thanks so much for that, Jennifer. I'll just get Garrod and Vinny on there now. Great, okay, so whoever wants to start us off with questions from the panel there.
I've just got a quick question. Well done, it was another great presentation, by the way. And it's a nice product. It's more got to do with, I just noticed about 80% of the cost is packaging rather than the cards. The cards, which are, I suppose, the real value in the project, are very, $135 for a pack. Whereas there's, out of the overall total, a lot of it is packaging. Is there any way of reducing that? It seems a lot of the cost is going into something that's not really the valuable part of it.
Well, the thing about Q is that some of the packaging cost is actually the structure of the game itself. So packaging by itself actually only accounts for 20%. but where that only accounts for 20 cent, but where that higher number came from is the fact that some of the plywood acts as the packaging as well.
Okay.
When it's in transport.
Very good. No, that was literally my only question on that. Thanks.
I have a couple of questions. I might just jump in. So you're saying like next steps for you guys would be to kind of test this in secondary schools in Ireland, and I think that's a great idea, just testing in general. But just wondering, in terms of the content and what's in the game, I know with menstrual health management, it really differs around the world, and culture has a really big impact on that, and not only in terms of, I guess, like beliefs of what you can and can't do. And I'm just wondering how much of that have you considered? Because I think in Ireland and in Zambia, that's going to be really different. So like, how are you respecting those cultural boundaries, and how are you not kind of, I guess there's a fine line between educating someone and discounting someone's beliefs. So just wondering how you would address that kind of tension and that balance with this game.
Yeah, so through research, we found out that the kind of stigmas and rumors and kind of different beliefs would vary from community to community. So that would have to be looked into even further somehow by talking to people from the community and gaining what they currently know and what they're being told, and then what information is being left out, and how we can bring in that kind of more scientific, factual information in a way that isn't kind of disrespecting their culture or the way that they teach things. That's going to be a really tricky balance, and that's where more testing is going to come into play. Testing in Ireland is probably going to be more about, does the game work? Are the categories okay? You know, are the facts being presented in a good way? And then that will have to be, you know, changed and tweaked and tested again to fit into the culture, because even just reading online and seeing different studies, there is a really big difference in the beliefs and the way that girls deal with periods. So some different communities would have disposable pads, and they would know kind of our perception of a menstrual health product, whereas others would have kind of no knowledge of it. They wouldn't even wear underwear. They would believe that it's linked to witchcraft, and there was a lot of, you know, there's a lot of variance and a lot of cultural aspects which may have to be addressed by tweaking cards for different communities to help overcome that.
Yeah, cool. And I think it's a really nice idea, the way that you're saying it's not just about girls and women, that it's a tool for everyone, and like getting everyone involved in that, I think, is really a vital way to make it kind of just not, it's not a women's problem, it's an everyone's problems, which I think that's really good. You guys just had like a slide there about the team and who you guys are, and I'm just wondering what your role in this, like your role in this project would be going forward, and how you'd like to see that, like what your ultimate goal as a team is it to kind of take this into the communities, or is it kind of I don't know, how would you see that working?
So ultimately our goal at the moment is to first bring it into Zambia. So Zambia run a program for vulnerable and orphan children in a city called Kabwe, just north of Lusaka. And Lusaka is where our product's produced. So we felt that it would be a really good first step to first go to Kabwe and to connect with Zambia and test the product out there, see if it works with those children. They have an education program, so it would be a brilliant first step before then moving to the north and the northwest, where UNICEF and Concern would do some work in schools and in communities there, where we could expand the product. But what Jennifer was saying earlier, there's so much potential in the cards to change them for different social issues as well. It doesn't have to be just about menstrual health. It could be about anything in any other country. So there's so much expandability there with the product, and the core product itself, the plywood frame, the packaging, the spinner, all that can stay the same. It's only the cards that have to change. And really, we've created a toolkit, and there's so much expandability, or so many options for expansion there.
Cool, thanks. Sounds good.
Yeah, great presentation and such an important issue. I know a lot of places where we work, particularly Nepal, this is a big issue. But I was just wondering whether you had been able to do any research on whether people generally play board games. Is there a culture to and an understanding of the concept of board games? Is that something you've been able to look into?
So I guess in terms of board games and toys in general in Zambia, we're kind of taking this as a method that's kind of for acting as a foundation for movers. So the movers we're talking about, like teachers, the school committee, and the parent teacher association. So Washington SDLS kind of recognize those people as the movers of society. So instead of just saying like Zambia plays games and stuff like that, we're kind of using Q as a foundation for these movers to kickstart in providing the correct information for these students to basically allow them to be the role models in their own households while also enhancing their innovativeness and like leadership capacities. So I guess, yeah, I'm sure everyone plays and everyone has games, but Q kind of acts as that foundation for students to kind of be role models in their own households and in their communities, and is starting or kickstarting that like perfection in sanitation in personal households and their own environment.
Cool, great. And just one other question. I was wondering if you'd looked into any alternatives to laser cutting. Not all places have laser cutters, or wondered if there's another manufacturing process you'd looked into.
Well, laser cutting was the decision that we made because there is a couple of companies in Lusaka who actually do laser cutting. They have 500 mil by 300 mil beds, which is perfect because we actually only need one sheet to create the whole plywood product. So that could be cut in a couple of minutes. And it's not overly expensive as well. So we did find that laser cutting was particularly appropriate here. And we also tried earlier in the conceptualization stage to use high impact polypropylene. But we found that the bending process was really just too time consuming and it couldn't be done as accurately as plywood. With plywood, we've created finger joints in the product as well. You might have seen it in the presentation, and that really acts to hold the whole product together. And plywood is quite a strong material as well. So in this case, we did find that it was the most appropriate material to use. But of course, there are other options. If we wanted to create a plastic product, that would be absolutely possible.
I have kind of a follow-on question from that as well. Just wondering, did you kind of give any considerations to, I guess, the flexibility of the game in terms of like, yes, there's cards and there's content that's laid out, but maybe like leaving space in that for people to fill in their own cards and their own content and things that they want to talk about? Just like, say, I don't know, you're talking about it being flexible for maybe having to adapt for different communities. Maybe that's the way that you do it, is actually you just let them fill in the gap themselves. And I'm just wondering, like, did you consider that, or was it kind of not really an option?
We did consider that, and some of the categories are a lot more open than the others. So like true or false is obviously a yes or no, and then there's some that are specifically scientific, but there's also cards that are role play or activity, and that's really where students have a chance to discuss their own experiences and to see how they would play out the scenario. There's not really a necessarily right or wrong answer. It's just to get them thinking about the topic and how they would react to a scenario or approach a situation or talk to their classmates. So that's kind of how we've been able to keep parts of the game open so that it's kind of engaging and it is student-led. The students do teach each other as well as themselves. So that's how we've kept it open. We haven't necessarily provided blank cards, but yeah.
Because I have a similar question. I know myself, I've had decks of cards where I've lost the odd card or two. How many cards are actually in there? Like, is there flexibility? If, like, it's great that there's durable materials, but what about if a card or two is actually lost? Can it still can you still play the game irrespective?
Yes, there's no defined number of cards which are absolutely essential. It's not like a deck of cards where you need every single card to play most games. For the matching game, for example, if you lose one card, then fair enough, you can take out the equivalent card or its opposite card, which has the text on it. and you can still play the rest of the game. So if you lose too many cards, then you may need a new deck. But ultimately, with the majority or even all of the games, it is possible to play even if you lose 1 or 2 cards. It's not game breaking in any way.
Yeah. How many cards, I suppose, are there per game? Is it like 10? Like just
so we haven't fully finished all of the cards yet, because we still need to do that testing in Zambia to see which ones work and which ones don't. But we are guessing that there's approximately 20 per deck.
Oh yeah, okay, that's useful. Thank you. Great presentation as well.
I have another question. Sorry, this one could be, it might be a bit too detailed, but just wondering, I guess when you take on any task that addresses like power structures in communities, you have to be aware of, I guess, the imbalance starting off. So just wondering, like with this, I know you were saying you have those kind of movers in the social community who you want to be able to hone their leadership and stuff, but just wondering in a classroom where you're saying like there could be teasing between boys and girls, and you're hoping that everyone gets involved and plays this, just wondering if there's any kind of like structure or guidance that comes along with this for like setting that as a safe space for people to talk about, and setting that as a safe space where you are addressing that, you know, half the people in the room might not know about menstrual health and might not be able to kind of identify with it, and then also the other half of the room might be kind of embarrassed. And I guess just, yeah, like setting the space for this to actually be able to work and develop. Have you thought about how you would do that, I guess?
So the key to kind of addressing the topic and setting up a safe space, I guess, would be having the teacher facilitate at least the first session. So there will have to be like guidelines for a teacher, maybe on how to set up the class, how to approach the topic, like how to explain the game, and then to just check in to make sure that people are being fair and that people's voices are being heard and that there isn't that teasing. The teasing from the research seems to come from a lack of understanding. So hopefully by presenting facts and answers that would address that. And yeah, it's really just the lack of education and the schools having the lack of resources to be able to educate. So this is going to be an educational resource and we'll need a teacher to facilitate it, to explain it and to ensure that it is used appropriately, and it completes our goals and aims for the product.
Cool, thanks. Great presentation.
Actually, just on that, if I might jump in very temporarily myself, it's normal, but actually it just got me thinking that I suppose when you're looking at the stage of the teacher, then actually had you thought around if teachers themselves, as you felt maybe uncomfortable around it, or kind of doing any kind of setting it up work with teachers actually, or maybe any kind of just like conversation with them in advance, or maybe any kind of like focus group, if it was going to be a few, like not focus group, but just like group conversation even in a school, how they felt about it and anything before kind of going to launch it. Was that something that you'd thought about or considered?
Okay, I'll take that one as well. Yeah, so through, as Garode mentioned, Zambia Ireland, they do teaching classes and for children, so getting in contact with them and being able to chat through it with them would be really helpful as well. It's something that we haven't thought about immediately because their focus right now has been on the content and the cards. But once that has been solidified and we've made progress on that, definitely getting a teacher's input would be hugely beneficial, especially if it's going to actually work, I guess, in a classroom environment. They would be the experts on that. Yeah.
Facilitators always play really crucial roles in how they do it. Yeah, great. Thanks, guys. Any last questions there from the panel? No, cool. Okay, well, thank you so much, guys. That was a fantastic presentation and really great product that you have there. So yeah, thanks again. So yeah, Jennifer, if you want to stop the screen sharing there, and I'll make you guys attendees once more. Okay, brilliant. So our next submission, our next project comes from Trinity College again, an engineering student there, Ruta. So she's going to present her project Energy Arc, which is a device that generates electricity by utilizing temperature difference when attached to a cooking instrument at the time of cooking. So Rita, I will set you up there.
All right. Okay. Hello, everyone. Yeah. Can you hear me?
Yeah, we can indeed. Yeah. See, we can see and hear you.
Well, thank you so much for skipping your late Saturday weekend sleep. And yeah.
Thank you for joining.
All right. Okay, so this is Energy Arc, which is an arc trying to produce clean electricity using cooking, which is an activity everyone does. So I'll just, okay. So an arc is a portable device that generates electricity using temperature difference by simply attaching onto any cooking vessel. Okay, so the idea behind this was to cater the underprivileged, which is like a lot of population in Mazabuka, Zambia. So we wanted to produce clean source of electricity because there are a lot of people with a really limited source of electricity and just on-grid electrical supply, almost around 75% of population. And it has, like, we are trying to mitigate power-related issues that kind of cascade into amenities like healthcare, education. It could be some sort of butterfly effect. Because we know, and as a person who actually experiences 8-hour daily power cuts, it is a similar case in Zambia as well since July 2015 as per our sources. It's a very crucial amenity, electricity. So it could lead to an encouragement in education, in healthcare, and other amenities that derive from electricity use. And this could also increase the interest in locals about electronics and technology, which could be a really good foundation for education again. This could lead to more educational centers, individuals who could come up with their own ideas using electricity. So it kind of indirectly boosts economy in Mazabuka. So this has its own unique ideas that are actually merging with Whitney and like EWB, all Zambia opportunities and what you guys are trying to inspire us to do. So, but the main ones that I could see merging with my product and your ideas are helping forced migrants, because this is a tool that is portable, that is foldable, and it could be affordable for people of any kind because it uses a very common activity, which is cooking. It improves resilience within communities by the way of improving quality of life. So the target group here is initially Mazabuka, Zambia, because they have really limited electricity. But now we could update this to underprivileged places in any developing countries, the ones that are refugees, where there are migrants, because as you can see in the picture, they use cooking vessels like pots where you can put that really bad cropped image of my device, but it could use any style of pots and vessels because of the signature use of hooks on the device. So what is the device? Like, how is it made? So it has predominantly silicon-based structure that sandwiches those Peltier models, which are the actual superstars here because they use temperature difference to generate electricity. And the silicon layers are 3D printed, which is a predominantly new idea, but very promising. It has foldable structure because of the silicon predominance, and it also has USB portal for universal access of electricity. So there are only 2 steps of using it. You simply have to hang the device onto any pot while cooking, and it uses USB point for electrical access. As you can see here again, I have divided those points into sturdy silicone handle while you detach it from the pot because maybe the product is hot. Because of its silicone layer though, it won't be heated up too much. And there are heat sinks on the outside that kind of cool down the Peltier, hence produce a temperature difference because of the cooking pot and the atmosphere that's been cooled down because of heat sinks. And there are Peltier wire connections sandwiched in the product, they are in series. So the peltier wire connections in the bottom right image, as you can see, they come out and go into a DC to DC 5-volt voltage regulator, which kind of regulates a steady current flow and helps us gain access to electricity. Why does it work? It uses the phenomenon of Seebeck effect, which is change in temperature at the junction of two dissimilar materials inside the Peltier models, inside those white cute little things, sorry for the informal language, that generates electricity. Those Peltier models are embedded in the silicon out layer, but as you could see in the in the previous picture, it's in a cutout. So the heat will actually be touching the Peltier's inside surface, while the heat sinks are actually connected using a thermal paste of the Peltier on the outside, so it balances out the heat transfer. Some salient features of this product. It's making consumers' life easy because all they have to do is attach onto the cooking pot of any nature. It's simple and intuitive design, so we could also outsource this design, so 3D makers, 3D printing makers could use it by themselves and actually build this for their own working. And it's using pre-existing common resource, which is cooking. So it's not using any more fuel or any more unnecessary input. And there not a lot of negative environmental impact. The only embedded embodied energy which you could see is due to 3D printing, the only energy heavily used. And it's fairly robust design due to heavy duty silicon covering, as you can see in the kitchen utensils. And the 3D, the thermoelectric generators are used of ceramics, so they withstand around 300 degrees Celsius. And it's pretty easy to use. So due to obvious reasons, the testing was on hold. But we have done with the previous prototype, as you can see on your right side, the ones with the flame paper thing, it was actually a proper circle. It was supposed to be a bed, but the newer prototype 2.0 is simply an arc that can attach to anything. And it has shown promise, as when you produce heat, it actually produces enough amount of electricity as per the manuals of the Peltier. So after further calculations, we would be able to see how much electricity it can actually generate. The making of it. So as per the dimensions given here, it's fairly handy device, almost the length of a ruler, even if you put it out flat. And the Peltier models are fairly small, but the beauty of this design is it could be changed in dimensions. If there are smaller parts, we would be able to use Peltier models that are even smaller in shapes, because there are other Peltier models that are 20 into 20 into 3.8 millimeters. And we could also use aluminum heat sinks, but there's also another promising research that is silicon heat sinks. That would mean we could 3D print everything at the same time, but we still have to do the further testing to use it actually. And a DC to DC 5 voltage regulator could be replaced with a battery. So whoever is using it can actually detach the battery and use it somewhere else. The cost analysis of the previous product, it was approximately 13.29 euros, but this was when there were 8 Peltier models. Now it has cut down to 4, so that changes a bit. But at the same time, you can still see, if you use the same calculation, it's around 200 Zambian kwatas, which is almost like a middle-range restaurant, what they would offer for a 3-course meal, which seems really pricey for people from underprivileged, but it's a heavy investment. And since it's from a previous prototype, we couldn't reduce it even more because of the 3D printing silicon ideology. So that's it, and I hope I was clear enough. Thank you so much.
I might jump in with a question, if possible. Great presentation. Super smart is my first thought, but just wondering, and this is probably, you might feel like a silly question, but if you're using this cooking with something hot, like for example, if you're boiling water, I know it's made out of silicone, so probably it's protected, but is there a chance that you could actually damage it, damage the tech side of stuff if there's water kind of overflowing onto it?
Yeah, that was one of my main problems, but because of the way the silicone is has its round corners, And when you pour water on silicone utensils, you can see it's kind of like sliding down. So the water won't be able to penetrate into the product because of the way it's sandwiching the Peltier models, as the shape would actually let the water slide. But it's actually a really good idea that I have to test if this goes forward.
Cool, thank you.
Thank you.
Thanks very much, Rita. Really, really interesting presentation. Did a huge amount of work on it as well. So congratulations.
Just a quick question. I know your testing got interrupted. Obviously, there was not a lot could be done about that. But from previous tests on earlier iterations, do you have an idea of the output?
Yes. So as per our previous documentation, there was around 7.5 hours of lighting that could be charged off. If you want me, I can share the screen for the report, but it basically had 2 AA batteries that could be charged per hour, which was 15%, which is like, you can actually get a lot of electricity at the end of the day. But of course, this was with a limited amount of current that was used while we were testing. So when you're actually using a heavy heat temperature difference, it would probably be more. So around 0.08 watts was the actual power that was outputted with 8 Peltiers with a limited current. But when it increases, we are sure to get more.
Okay, and what would you say is there are several, I suppose, components to it. Which would you say is the least robust? If one component was to go, which one would you identify as the?
It's more about the connections I'm worried about, like the wires in the middle. If you saw here, so in the exploded view, as you can see, there are like tiny wires with like their crisp 90 degrees turn. It would be possible to have a different 3D model for it, but those, along with the connection between the aluminum heat sinks and the Peltier itself, the thermal paste might burn off after a heavy use because of the extreme heat transfer. So I think that's it's a problem that could happen, but because it's fairly easy to obtain the thermal paste, it's possible to, for the mechanics there to fix it.
Okay, thank you. Well done on the presentation as well.
I have another question and might just jump in. Just wondering if you kind of gave any considerations to like misuse. So, you know, people use this while cooking, right? But what if actually I decide I need, like, you know, the energy more, so I just start cooking things for the sake of it, and I guess how that's wasteful in other ways. Did you kind of think about, yeah, I guess, did you have any considerations for like tackling that, or what the impact of that might be?
That's a really good question, because people have a tendency of finding more ways to use one thing, and that could lead to problems. I would say, as this was targeted for people who are always like with minimal amount of resources, so it was not a problem, because even for them, it's like, it's really pious. Even the art of cooking for a mass amount of people, they have to do it together. They have to mix things together. So sometimes they are really limited on the resources. So it's more than this is a part, it's in a form of a gift, more than this acts as an opportunity for misuse of cooking. But that could also mean they will actually get healthier if they actually eat more. So that could be a positive side effect. But thank you.
Thanks.
I suppose I had another similar question around misuse. Is it, and kind of security, first of all, is it kind of safe if you're leaving it in a home there? If there's kids running around, are they likely to I don't know, could they pull out wires and break it? And similarly, if it's kind of relatively expensive for a low income community, how would security again be kind of factored into that?
So the major part of security, as you said, was pulling out the wires, harming the kids in the process. Because of its 3D structure, the 3D structure has the main base layer first built, and then you have the pelleters joined with the aluminum sinks, and then the above silicon layer kind of like fuses with the whole model. So as you saw in this exploded move, it's actually pretty much seamless. So there's like a little chance of ripping things apart, because everything at the end would look almost like full of rubber. It's almost like a rubber wall with heat sinks on the sides. But as you said, there could be problems of short circuiting with the power bands. So that is something that is of concern, and I'll try to make it even more seamless and less able to like, because of this sturdy silicon nature, it is hard to like pull things apart.
Okay.
But yeah.
Great, and great presentation. Well done.
Thank you so much.
Any last questions there, guys, for Richard?
Yeah, I just have a query. Thanks for the presentation. Obviously, quite a bit of thought has gone into this. I was just, because obviously this is actually, you know, quite a technical piece of equipment when it's all put together. I was just wondering, with regard to its actual implementation, you know, on site, would the idea be it would be manufactured, for example, here and, you know, let's say shipped or flown over, or would the idea is that it's actually all manufactured somewhere in Zambia and distributed locally? I was just wondering, had you thought about that?
Yeah, when I was running this thought experiment with people about how this would be manufactured first in Ireland, because we have so many 3D printers here, and then it could be shifted there. But it could also work as a starting point for them to produce their own 3D printers if possible. It's more like a chicken and egg situation, like giving birth of 3D printers from 3D printers kind of situation. So like first it will be manufactured in Ireland, but once it's exported there, and if people actually start using it in huge quantities, there will be possible that they can make businesses out of the electricity this produces, hence helping them create or build even more different machines that could also produce these kind of things at that place. But the starting point would be in Ireland, I would say.
Yeah, I was wondering if you'd had a thought of alternatives to 3D printing silicone, because it's not really widely available really to 3D print silicone. I just wondered if you'd looked at any other processes.
So my initial idea was of using a steel bracket for the peltiers to keep them in place. At the same time, because they would have joints, they'll be moving, and they would be covered with leather or like nylon kind of structure, kind of material. So it kind of like helps it keep in place. So it's still inert, it does not conduct electricity, so it will be safe. But at the same time, since nylon would be heat resistant, I would say fire resistant, it would also help with the bracketing and the safety of it, but it would be really less substantial.
Okay, cool. And I was wondering if you designed it to be repaired, and if repair could be done locally at all.
Yeah, one of the main paradox I would say was either it would be easily repairable, or it would lead to ripping things off at home and twinkling with the wires. So I'm actually debating if I should leave the seamlessness of the silicone on the bracket on the layer, or if I should actually have some sort of like pushing down buttons in the layer made of silicone itself, like some kind of like push in buttons that we use for shirts and all. So we could use those on the wall itself and like take them off if something goes awry. Thank you.
Thanks very much, Rucha. So yeah, if there's no more questions for Rucha, then we'll move on to our next presenter. So thanks again, Rucha. I'll make you attendee again. And if you want to stop the screen share there as well, that would be great, thank you. Sorry, I'm also having some technical issues myself, as this sometimes comes our way these days. But anyway, so hopefully you'll all still be able to hear me. So our next presenter now comes to us from National College of Art and Design again, Sinead. So Sinead's going to present her project, Science Cubes. which is takeaway game that aims to inspire teachers and engage children in discovering simple science experiments through problem-solving cubes. So Sinead, I will get you up there now. Hi, Sinead.
Hi there, how are you?
Good, thanks.
How's it going? Hello to everybody. I'm just going to share my screen there.
Yep.
And here we go. I'll bring you to the start. Okay, so my product is Science Cubes, and it's a game. So I'm just going to quickly run through research for it, some gameplay. We're going to watch a little short video and then why it is relevant. So there we go. The Science Cubes are a building-based infographic game for children, and they're also a tool for teachers with large classes. You can see a picture of the Science Cubes there, and there's no wording, it's just information in picture form. From the start of this was when Liam came in and gave us a presentation about the school in Cabway, and from this I took some inspiration, and I looked at the garden section, the green gardens, and how to help propagate plants using basic materials such as plastic bottle, clay, water, seeds, stuff that they would have. And then from there, I looked at one of the questions I kept coming back to was like how to teach, how to transfer these new skills. And so I looked at making a cube game. This here is the template. You fold in the green sides and into a cube, and you're left with the 6 faces free. This game is a portable game. It can be played in the classroom to groups or individuals. It's inclusive, it doesn't look for language. So with all the multiple languages in Zambia, it is, it's just the pictures that they look at. It's tactile, it's about building, and it's also something that can be taken away and into the community. The gameplay itself is 9 cubes that will create 6 experiments, 1 for each face of the cube. There is 1 master block and 1 cube game for 1 cube game, and it's a build and print, and it's color coded. The gameplay goes as follows: like the teacher will call the color, the student turns the face to the color. The student then has to work out the correct sequence of the cubes, which laid out 3 by 3 all the cubes start with the pieces that are needed for the experiment. After they put the correct sequence together, then there is the teacher then demonstrates the science experiment. There's a quick little video here, and it just explains visually a little bit better than I can in words. So enjoy the music. So that probably did a little bit of a better job explaining things. I looked at originally the reason it's Science Cubes comes from the fact that there is a directive from the government to say that all schools must teach science. So originally looking at green gardens, but then the idea of the propagating system, and the propagating system is simple, is a glass house, where it like teaches condensation, and that's where that came from. there. I also looked at like ASHTR, which is the Irish Framework for Early Learning, as a way to implement that in the classrooms as well. It's a way of like learning to make sense of the world and observation and thinking. The game works as well, right? Because it's easily repeated. It can be taken away by the children once the master blocks, which are like this. Those master blocks can be made, they can be printed onto anything. So it comes with a template, but it doesn't necessarily have to stick to the template, and be made on any surface. So there's a potential there for creative expansion of the game. There is also difficulty levels, and learning content can be expanded as well. So I showed you in the video 6 cubes. You can do it with 3, you can do it with ideally 9 if you want a more complicated or a more advanced experiment. The learning content doesn't always, there's potential for it to be adapted. It doesn't always have to be science-based, so you can teach hygiene or gardening or nutrition, maths through this. Further development of this would be great in testing in the classroom and seeing how it actually plays out. And then the master blocks to make it clearer. However, there is a high tradition of word carving in Zambia. So I used Lino and carved out the instructions on that. You can easily, there's an opportunity there for them to be made in Zambia, and an employment opportunity there. Okay, that's it. Thank you very much. If you have any questions, if you want to email me about anything as well, my email is at the bottom there, so there's no problem.
Thanks very much, Nate. Really interesting, great to see the little short video there. Yeah, whoever has first question there wants to kick us off, I'll pass over to our panel.
I don't have any questions, just to say I thought it was great. It was really good.
Thank you. That's great. I mean, I'm sure there's loads of stuff I've left out and haven't gotten to, but yeah, I don't, any questions at all? And
I guess actually I do have a question. Would you see this kind of working? I guess you're saying like it works in a classroom for if there's a teacher and there's lots of kids. Would you see it being like one for the entire class, or like one per child, or like work in groups? Or
yeah, it's hopefully it would work in groups, so that if a lot of the classrooms in Zambia are overpopulated, a lot of underfunding, you know, like the directive is for there to be science to be taught, but like there's no science labs, and you know they're underfunded and overcrowded, but like, you know, the enthusiasm to learn is there. Lots of, we looked at the Sable School in Kabwe, and a lot of the students come from miles to go to school, you know. They come from the Makalulu slum, and they walk for hours in the morning to make sure they get there. So when you get there is a large class. So if there are 6 cubes, there, you know, you group the students into each one, or sorry, 9 cubes. So you group the students into the equivalent number of groups. So for the master cubes, so if you're starting on a very simple experiment or taught subject, if it's 3 cubes, you'll have 3 large groups, and then the students get to build and see how to build. So there'd be various different age gaps and age groups within the class. So, you know, the hope would be that the groups would be of mixed levels, so the younger and older can teach each other. The opportunity here is also that once they've learned how to do this, they can bring this out into the community. The game can be taken home with them. So there's a lot of like students that don't get the opportunity to go to the college or to the school. They, you know, for whatever reason, a lot of girls don't complete their education. You know, a lot of the communities need people at home as well, looking after parents. So this is an opportunity for some of the children to learn it and bring it back, and then play and teach. Like children, it's a chance for the children to be children also, and not to have the pressures that are there every day. It's a chance for them to expand on that. So yeah, in groups, sorry to go back to your question, but in groups, to be taught it in groups and then to play it. And, you know, they'd be creative as well. Like, you know, I stacked it flat on the ground, on the surface, but you could build it up, or, you know, there's totally a lot of different ways to do it. And, you know, what's great about further testing would be, you know, seeing how children react to it and what they see in it. Like, I know what I can see, but what they see and the potential they have is completely different. So it also comes with a booklet for the teachers. So like, a lot of the teachers don't have a large education, you know, they'd be lacking. They want science being taught, but there's a lack in educated science teachers. So the booklet comes with the basic tests. Let's say the one that was in the video was for like air compression. But like, let's say you do density, and like you just need like a plastic bottle, you need oil, water, and then you pour them in, and you can show the levels of liquid density. And then after that, it's like adding different liquids, it's expanding out the experiment, and then looking to the children to add things to see what sinks and floats and expand the experiment out again. So this would be in the booklet. And so, yeah, so there's lots of expansion and possibility within it.
Cool, yeah, because I was going to ask, was there support for the teacher, but that sounds good.
Yes, definitely, because it's, you know, it's something that's very important. You know, you want to see that the teacher is comfortable teaching it, you know, and all the experiments that are in this are plastic bottle experiments. So they use very minimal tools. So you don't have to have a science lab, you don't have to have, you know, expensive science equipment, which they won't have, but it's just looking at what is available like locally, and then how to use that to your advantage.
Cool, thanks.
Cool, thank you very much for your question. Any other questions?
No, it's actually, your presentation was actually very self-explanatory, so
okay.
I think you answered every question I had on it. Really nice presentation. So,
thank you.
I think that's it from me.
Cool.
Brilliant. Okay. Well, thanks a million, Sinead. Delighted to have you here with us. So, well, keep touch, and I'll make you 20 again.
Thank you very much. Thanks, guys, for the opportunity.
So we have our final presentation now from NCAD again, and it's Tyke, who's going to introduce us to our shredded bottle shredder. So I remember it still from back in the day, so I'm looking forward to seeing how it's come along. So the shredded bottle shredder is a safe and robust bottle shredding solution that can be used for building and for craft purposes. So Tyke, I will set you up there now.
Hey guys, how's it going? How are things? Hope you're all keeping well. I can't actually hear you guys at the moment. Okay.
Oh yeah, the guys are all muted, but they'll.
Oh, okay, yeah. I'm going to my share screen now. Okay, here we go. So I'm Tyke O'Connell. I'm from the National College of Art and Design, Dublin, and I'm going to be presenting Shred It, the on-the-go bottle shredder. Oh, sorry, I'll just remove this. Okay. So my project mission statement was to create, enable, and empower the students of Kabwe, Zambia. So through the early ideation phase of my project, I identified that there was a lack of building and craft materials on hand. So I saw an opportunity through the overconsumption of plastic bottles with minimal to no adequate recycling facilities. So as you know, like plastic bottles can often act as a like they're just like, I don't know, they're like harsh looking on the landscape. So yeah, so through my early ideation phase, I tried to involve the plastic bottle, implementing it in the likes of a condensation catcher, where I created a plastic shredding and wove it to create like a tarpon. Similarly, I also use a similar technique in a solar food dryer, creating a drying tray out of woven plastic shred. So throughout all my concepts, I used the material of the plastic shredding to kind of as like a focus point. So as you can see from this, I was quite material conscious. So as we all know, PET plastic has many beneficial properties, making it ideal for lots of useful applications. So for instance, it's highly flexible, making it practically shatter resistant. As well as this, it can also withstand a broad range of temperatures, ideal for the climate of Kabwe. Also, it has excellent resistance to oils, greases, and diluted acids. So bringing this forward to my concept phase, I kind of realized that PET plastic was something that I wanted to follow through with. So for this, it was important that I could create an actual tooling that would enable and empower a student to shred the bottles, etc., etc. So here comes the solution, shred it. So we can see that you have your tooling as well as the byproduct of the like plastic shredded bottle. So bringing us now to shred it. So shred it is child friendly and can be manufactured in an untechnical setting using minimal components and uncomplicated instructions. I took the idea from a pencil sharpener where I removed the screws and blade and set it into a timber handle. So as we can see, it consists of 2 slots on either end, both of which hold a blade and a screw. So each slot has a different depth, allowing for a different gauge of plastic shredding. So I looked at the easiest way of setting in a blade to like a piece of timber or any alternative material. So how it works. So step 1, the student would make the bottle shredder. I was thinking that the student could actually make the handle, and then the school could provide the blade or the screws. So this would bring about like a kind of like a, I don't know, like the students are getting to learn how to like make, and there could be like a jig supplied or something to aid them in the construction of it. Step 2, the students would collect PET bottles, which as we've already identified are a scourge to the landscape. So this is like this is enabling them to upcycle these plastic bottles and helps out with recycling them, I suppose. So step 3 is shredding the bottles using the tool. So this can be easily done by cutting the base of the bottle off and then setting it into the desired slot, which will give them the gauge that they require for the application. So when the student has set the bottle into the slot, they can then revolve the bottle, and they'll get a strand of plastic which they can pull, and that gives them their material, their finished material. So then step 4 is applying the shredded material to a range of functions. So this is really important to the design, as a material is hugely beneficial for both craft and construction. It can be applied to a huge range of different useful purposes. Like, so for instance, it can be used for it can be woven into the seating and backing of outdoor furniture. or alternatively to help the agricultural sector in doing joint lashing for fencing or trellises. It can also be used for, say, in craft, where people can make woven baskets or hammocks, and there's other opportunities for likes of mats as they enter their homes, or and much more. I'd like to also to point out that I made a brush which was highly effective actually, and it consisted of two plastic bottles. So the strands that you get from the bottle can be as big as a bottle, and you can have it to any kind of like your required kind of gauge. So finally, moving on to the opportunity to teach about knots, lashing, and different techniques of weaving. There can be a supply booklet which takes them through visuals, like how they can step by step put together knots. So to finish out, I'd like to just summarize and say I think that Shredit can bring about many opportunities for both small cottage industries, for instance, making the baskets, the hammocks, and etc. And it can also serve as a purpose for the students to bring it back to their homes as like a take-home kind of tool, where they can actually show their peers and educate their peers on how to bring about like this change. So all in all, it is a tool to enable and empower the students of Cabway Zambia. Thanks, guys. I hope you have some good questions.
I'll go with the first question, I suppose. Have you thought in terms of, I suppose, maybe microplastics that may be released into the environment if you're doing this kind of shredding? And I know, I suppose some communities that I've worked in previously, they often.
Sorry, I can't actually hear.
Can you hear me now?
Hey, sorry, I didn't actually hear. Apologies.
Okay, no problem.
I don't understand. Hayes.
Can you hear me now?
I can hear you now. Yeah, brilliant.
Yeah, perfect. I suppose my question is just around the potential for microplastics releasing into the environment if you're doing the shredding. And a second question, I suppose, a few communities that I've worked in previously, particularly low-income communities, they often collect plastic bottles and drop them off to a place because they receive some cash for bringing in the plastic bottles and recycling. So just did you think about that, I suppose, when developing the concept that people may not want to shred the plastic bottles, and is there an opportunity for other materials maybe?
So I was thinking more so in the lines of, like, say, it is an optimal material for the likes of kind of like doing landings and that, because it is so resilient. So I think that there definitely is the opportunity there for them to shred as they need, but they could definitely I could definitely research into alternative materials that could be used. But like say, in terms of microplastics being released into the environment, from what research I've there's an awful lot of plastic kind of pollutants in the area already. So it's kind of like catch-21 of, like, say, when I was shredding it personally, I didn't see any kind of microplastic. You were just getting one big strand of plastic that was like, it was all clean cut, and then you could remove whatever you needed from that and maybe save the excess for a later stage.
Okay, and I think the idea, like, of the knots and teaching about the knots, it's brilliant. Really good presentation. Thank you.
Brilliant, thanks.
Hi, yeah, great presentation. Really enjoyed it. I just had one question on whether you'd looked into existing tools for shredding plastics that sort of currently exist and how your tool compares to them, whether you looked into, I'm not sure if you're aware of the precious plastics sort of movement and all the tools they offer. Just wondered if you had any thoughts on that.
Yeah, so I had actually looked at some existing tools, and I kind of wanted to create a tooling that could be easily accessible and made within the schools, and so creating a child-friendly and untechnical tool for like say development. And I just figured that, say, within their community, it offers so much potential in that it's not just limited to say to the likes of their hammocks or the mats. So it's a tool that is kind of opens them up for like kind of anything really. Like say from what I made from it, you can see that like with the condensation catcher and that, like it has kind of endless opportunities. So it was just more so creating a easily accessible tool that could be that you can change your blades in and out as you need. Hello?
Yeah, I've got a quick query for you there, Ty. Maybe I missed it in the present. How exactly is the actual shredder manufactured?
So I can bring you up to the slide. So the shredder would be made of, so alternatively it could just be a branch where you've cut your piece out of it, your segment out of it, and basically the block of timber acts as your handle, where then you have your slots made for actually putting your bottle into, and then the blade in. So taking the idea from a pair, so you can, like, basically they can cut their the piece of wood to shape or to form, like, and then so I've made it as so that it is as untechnical as possible. Like, I hope that answers your question.
I was just wondering, really, how do you get the metal blades into it? I'm just trying to see from the picture how they fit in.
Okay, so like say just with a saw, you can cut your notch, which your blade is so it's just like, say, it's just on. I hope you guys can see the cursor there.
Yeah.
So it's set in there, and then using the screw from, well, say I use the screw from a pair. It's then set in and like fastened into place using the screw.
Oh, okay, so that allows it then to be ultimately replaceable at some point in the future.
Yeah, exactly. Yeah.
Okay. Yeah.
I just have a quick question as well. Just wondering if you thought about like sourcing these materials in local communities, like where they might get their hands on blades, or did you do any kind of research into the costs of making that and stuff?
Yeah, so I was thinking they could use, so in terms of the blades and screws, maybe that could be brought in by the school. Like say, I was just thinking like as like say a cheap, well, a relatively cheap kind of material, or like just for like sourcing in general, the school could go about bringing that about. And then screws could maybe be taken out of like say old things that have just been like kind of like dumped, or so that they can like repurpose the screws and cut them to size or whatever.
Cool, thanks. I think, is that all the questions?
Yeah. Thanks, Olivia. Sorry, I'm having some terrible connection issues here, so thank you for the support. Cool. So yeah, no, if there's no more questions there for Ty, then thanks a million for your presentation. And actually, and I hope you can all hear me okay here now, we do actually have one final presentation, hot off the press, from Trinity. The team is Charclean, and Angie is going to present. So I'm just going to set up Angie there now. So yeah, if you want to finish screen sharing, and I'll make you panelist again, Doug.
Thanks very much, guys. See you later.
Thanks, Doug. Okay, so Angie. So over to you, Angie, for Charclean. Okay, we don't see you or hear you yet, Angie, but it might just take a moment or two, maybe a connection. Might be in the same boat as myself.
And you're muted, Angie.
Yeah, you're.
Hi, everyone. Sorry, 1 second. I'm trying to get the presentation up.
No problem.
Unfortunately, Zoom is not allowing me to share my screen. Would it be possible to make Kleena, the second member of the group here, a panelist as well, so she can share the screen for me? It's listing some privacy issues.
Yeah, sure, I can set up Kleena there. That's no problem. I'll just do the switch. Oh God, sorry. That was not meant to be. Brian, apologies about that. Sorry, Brian. Fun and games with Zoom. So, Kleena. No.
Hi, sorry, I'll just get it up now. 2 seconds. Everybody see it?
Yeah, we can. Thanks, Tina.
Yeah. Okay. I'll just wait for Angie to start whenever she's ready.
Oh, sorry, Kleena, there was a bit of misunderstanding. Are you not going to present it now? You still want Angie
No,
to present
both of us are
okay.
both of us are going to present. Sorry.
Okay. Yeah, no problem.
Sorry for the miscommunication.
That's okay.
Hi, sorry about that. Yeah, Kleena is just going to have the slides up and I'll be taking through the
no problem, yeah.
Sorry about that. So hi, everyone. Thank you very much for having us here today. As we said, my name is Angie, here with Kleena. We're from Trinity College and we're here to talk to you about Charclean Purity on Tap. So I'll ask you to walk you through the project. One of the key components of the Zambian economy is the mining industry. In 2019, it accounted for 13% of the national GDP. Unfortunately, as extensive as the mining activities are, as is the extensive water pollution that has resulted from the mining waste. So what we've done to address this issue is a very simple water filter that uses bone char filtration. Bone char powder is made from animal bones that would normally be considered household waste. And as you can see on the picture on the bottom right of the slide, this is a charred bone after having been in a furnace. So the fine powder that is produced from the furnace is then made into small pellets that are made using the mold that is on the SolidWorks sketch on the right. And these small pellets are housed on the two heads of the PVC coupling, so showed on the left SolidWorks sketch. And that is our filter. It's very simple. So what is the challenge that we faced and wanted to solve? Basically, we came up with this product when we read about the long-standing lawsuit. The villagers of Shimulala, a small village in the Copperbelt region of Zambia, brought against the corporation Vedanta Resources Limited, who owns the Konkala mines. These are the largest mines in Africa, and they mine copper. So because of the negligence of the company, there has been extensive water pollution that has destroyed all aquatic life and has actually damaged the health of the inhabitants as well. As you can see on the picture, the water on the left has this yellow color due to the large amounts of sulfur and other heavy metals that are in it. The inhabitants of the community are forced to ingest sulfuric acid essentially on a daily basis because they don't have access to clean water. And it's not just the villages of Shimulala. 40% of the population doesn't have access to clean water. That's actually 6.8 million people. So how does charcoaling work? The way it works is our filter is attached to the central borehole of the village. Many of the rural communities in Zambia only have a central borehole as the main water source of their community. So our PVC coupling pictured here on the sketch and the SolidWorks sketch is attached to the borehole. There are two pellets that act as filters on either end. The water simply goes through the unit. The pellets hold the impurities. And as the water passes through the casing and into the second filter, the water then exits free of sulfur and heavy chemicals. It's as simple as that. So how did we go about designing the product? Well, it's based on the three pillars of user-centered design. Those are sustainability, cost, and community. So one of the key features that drew us to bone char filtration is the fact that the bone char powder is reusable. After approximately 6 months of use, when the filter will need a change, instead of needing to produce more and more bone char, we can simply take the pellets that we already used, wash them with hot water to remove impurities, and then reheat them to 500 degrees Celsius, and it's ready to be used again. We're also making sure to use pre-existing infrastructure. So the furnace is available in the mines and the local communities and the central borehole. So we don't have to intrude further in an already polluted environment. It's also really important to note that we're using the mine furnaces during their cool down periods. So we're actually taking advantage of a lot of excess heat that would normally be lost to the environment at no extra cost to the company or the community. Because the community is so heavily involved in producing their own bone char powder and their own molds through scrap metals or any materials they have available, the only component that actually needs to be purchased is the PVC coupling, which ranges from $6 to $15 depending on the size and is widely available commercially. There's also potential for 3D printing the coupling, and we're going to look into experimenting with different materials that would allow us to bring the cost down. So that brings us into how we can further expand our business idea. Just to give you a better understanding of the situation in Zambia, while the product was mainly designed to help the villagers of Shimulala, the mining industry is very extensive all across the country. There are currently 13 different mining projects that are active that are owned by 12 international companies. As we said, that's 13% of the annual GDP. And unfortunately, there's a staggering figure that shows that while that's the case and the pollution is extensive, the government is not taking further measures to deal with it. Even though in recent years, we've seen an increase in the funds allocated for water sanitation projects. For instance, in 2019, that was $156 million. Over half of those funds are reported to be misappropriated from the community. So less than 75 million actually reaches the hands of the people that need it the most. And that brings us on what we can do to further develop our product in the future. So we have a series of lab tests that we would like to carry out. Those would include experimenting with different chemicals that are present in the water and varying their concentration to see how our bone char filter holds up against them. And that would allow us to determine both the correct concentration of bone char in the pellets that we would need to increase the lifespan of the filter and determine the details like the filtration capacity and rate. We also would like to carry out tests for the physical structure, namely CFD fatigue testing and destructive wear testing, because we expect wear and tear to result from screwing the filter on the borehole and off, or the chemicals passing through. And we would also experiment with different water pressures to see if that would affect the internal structure of the plastic. And lastly, when it comes to 3D printing, we would like to explore this option with different infill shapes and amounts, because that would allow us to experiment with bring down the cost, reduce the printing time, while also maximizing the structural integrity of our product. And that's all from us. Thank you for your attention. If you have any questions, we'll happily answer them.
Thanks very much for the presentation, Angie. Do we have any questions there from the panel at the moment, guys?
Yeah, I have a few. Just wondering, like, if this is to break down or something, how easily can you access it and service it?
It's very easy, and I think the main point that we wanted to get across was the fact that after the first installment, it's completely bestowed to the community. So they make the bone chair. If they need to replace it, they will know how to do so. They're only operating equipment like the furnaces that they're already familiar with. And we will obviously be supplying extras of the PVC coupling just in case there is extensive damage, like something cracks, for instance. But every single component is made by the community with their locally sourced materials. So there is no need for them to wait for external help to arrive. They can take care of it all by themselves.
And just wondering as well, what, like, how have you compared this to other kind of carbon-based filters or just water filtration systems? Have you kind of compared to those?
So a lot of the other filtration systems that are available are quite bulky. First of all, they need a lot more equipment, a lot more technical knowledge to be installed and maintained. So we found that the fact that this is just a simple device that can be attached to the water source makes it a lot easier. And we also found that bone chair is actually ideal for the kind of chemicals that are present in most African regions, particularly in Zambia as well, which are the heavy metals like lead, the sulfates, the fluorides, and other chemicals like that. So we explored electrolysis and fluoridation when researching, but we found that this is ideal for that location, and it's the fact that it's reusable, it's a huge plus. We don't need to further pollute the environment by adding more chemicals to clean the water. And yeah, does that answer your question?
Yeah, thanks.
Thank you.
I had a question about the PVC coupling.
Mm-hmm.
Was that a standard pipe fitting, or is it quite a unique bespoke design?
No, we just modeled it on SolidWorks for our own benefit of understanding the structure, but it's a widely commercially available PVC coupling that can be found in most hardware stores. And we would just pick the appropriate size of the diameter for the borehole.
Okay, cool. So why would you 3D print it? What was the thought there?
We were asked if there was 3D printing potential at previous presentations, and one of the thoughts we had was that potentially if there was a location where there were specific geotechnical details, like there was an unusually high water pressure, for instance, perhaps that water pressure would damage the internal structure of the standard PVC coupling. So we would have the opportunity to tailor our device to the specific needs of that community. But of course, we acknowledge that 3D printing is obviously a lot more costly than a standard component that can be purchased. So we would only do it in very particular cases or just for further experimentation to test materials.
Okay, cool. Yeah, 3D printing can tend to be a bit porous. So at high pressure, you may find difficulty with that, but just with knowing. And I was wondering, when would the community know when to change the bone jar?
So for that, we would first have carried out experiments testing the lifespan depending on the concentration. So we would be able to give the community an accurate timeline of when to know. And we would also, obviously, because the color of the water is so obviously yellow, at the start, whenever they start noticing that there are spots of yellow coming out of where it should be clear water, they would know themselves by eye, but we would have given a clear timeline to watch the concentration of the chemicals that have destroyed the pellets and that they would need to be changed. I couldn't give you an exact figure right now since we haven't had the chance to test it in a lab. Thank you.
Just jumping on the back of that question as well,
Mm-hmm.
wondering, I guess, have you thought about any considerations about how like you hand this off to community to self-manage? Just because like, I guess if there's difference in concentration levels and stuff, that kind of data you provide won't always hold up. So just wondering if you considered like how they might test the water, how you could kind of make that a bit more reliable and robust and not just be kind of like a based on eye or taste or kind of thing.
That's a very good point. And so for instance, we have addressed that for areas that are perhaps the water has a heavier sulfur concentration. Just adding a little bit of sodium bicarbonate allows in the bone char allows them to further neutralize the acid, and it actually makes the bone char more effective when neutralizing the other chemicals. So we would I suppose in the pilot stage of implementing this, we would have a look at the chemicals that are prevalent in that particular situation and would advise about any changes in the general structure. But we feel that the areas that are most affected near the mining projects would face very similar concentrations, and because they're very limited to one source of water, since local rivers are very polluted, there wouldn't be a need for too much like difference and I guess ambiguity in how they would operate it.
Great, thanks.
Thank you.
A quick one. You mentioned reheating to 500 degrees, the char.
Mm-hmm.
Did you say that was going to be used existing processes, the cool down phase of the furnaces and like that?
Yeah, so initially when we're first incinerating the actual bones, you need 700 degrees Celsius for about 5 minutes to perform the incineration and have the powder. When it's reheated though, to just remove the impurities after it's been washed, it's at 500. And we found that those temperatures correspond with the cool down periods of mining furnaces in Zambia.
Okay, and will there be access to the mining furnaces?
Yes, because we thought that because the rural areas greatly depend on the mining industry as their source of income, the local industry revolves around that, and a lot of the people would potentially be working there as well. So we thought that a chance to use the company's mines would foster better relationships with the company itself, and it could be an exciting investment opportunity on their part.
So it really means getting the mining company on board.
Yes, for sure. But we also anticipate that there will be furnaces available in some small local businesses when it comes to making products and other devices that they would normally use for other purposes. So we anticipate that we will be able to use those as well.
Okay, thank you.
Thank you.
Yeah, I had a similar question. I suppose, so the understanding then is you are reliant on the mining companies to use their furnaces to create the bone char, is that correct?
Yeah, largely so, yes. But again, we think that because we're specifically mentioning that we would only use them during the cool down period where they're not actually used at that time and it's just heat being lost, we're not asking the company to add further costs by extending the operating hours of the furnaces. We're just taking advantage of a period when they're not used for the community's gain.
I suppose if they're already involved in lawsuits in terms of the water quality, they may not be that open to anything that may be seen to be improving water quality. So it's just, I suppose, have you thought about if you can't access the mining companies, if there are other options?
Yes, we were considering looking into how we could make such a furnace from clay and other materials available. I think one of the AWB members that was at Trinity mentioned that a few years back there was a project that actually made such a furnace or a makeshift oven that could produce bone char. So we wanted to find out some more information about that and look into and see how then the project could be entirely bestowed to the community and they wouldn't need to rely on the mining company or other local businesses.
Okay, yeah, great presentation though, very interesting, thank you.
Thank you very much.
Thank you.
Thanks very much.
Are there any more questions?
Yeah, there we go. Okay. Okay, great. If not, then guys, well, they're all our presentations for today. So we're going to take a short break now, and the judges are going to take a well-deserved break, and then also deliberate over who'll be announced as the winners. So they'll be back on in about 15 to 20 minutes. So yeah, if all the attendees and students just want to take a break for that time, and then want to come back on, the judges are going to leave and have separate meeting to discuss. But yeah, we should be on again to announce the winners in around 15-20 minutes. Okay, thanks very much, guys. Anything else anyone wants to add from there from the journal? No?
No.
Cool. Good stuff. Okay. Thanks very much then, guys. You attendees again, guys.
Greetings.
Hey guys, welcome back. Yeah, so I guess will I pass over to you now, Declan, if whenever you're ready to make the announcement.
Yeah. How did the break go?
Grant, now we just yeah, we all just chilled out a bit.
Everyone's back in again.
Yeah, I think we've got everyone now from the panel. Yeah.
All right. Well, first of all, obviously we were all very impressed with all the work that went into it this year. So congratulations to everyone on the presentations. It was a particularly difficult year. It's not an easy thing to do anyway. It's sort of a very different way of thinking about things outside your normal coursework. And then with disruptions caused by the pandemic and everything else, it hasn't been an easy year for it. But after the deliberations, we sort of had a unanimous decision between the judges for once. I'll start first of all with the innovation awards. Every year we have an overall winner, but we also have innovation awards. So projects which we think need a little bit more work, but we definitely have they definitely have a future in what we're thinking in Zambia. This year we actually have a joint innovation award. Both projects had a lot of merit, but both projects we think could work very well together. So that is an option, either to develop them separately or join them together, join the teams together to do it. So this year's innovation awards go jointly to Q and Science Cubes. We're definitely impressed with the educational potential of them, and the fact that I think the Science Cubes looked into the local wood carving tradition as well. We think that there could be a crossover there between both projects. So well done to both those teams.
Congratulations, guys.
Again, there was a little bit of deliberation, as always, about the winner, the overall winner. There were some really excellent projects this year, but some that were going to be difficult to implement. And generally, the overall winner is one that we feel is pretty much ready to go. And that was the case with this. It looked into sort of the local need, how it could be implemented by the community. It solved the problem, and basically would take very little to implement it on the ground. So this year's overall winner of Where There Is No Engineer is Flyco.
Okay, congrats, guys.
And the silent applause.
Yeah, no, I just thought, to make it a bit more natural, will I maybe promote the guys to panelists again if they want to make any comments or any questions?
Yeah.
I think that would be something nice to do. So, Flyco guys.
As I said, it's the overall winner is always one that's pretty much easy to implement straight away. So that's why we chose that project. It sort of thought about it the whole way through, and it would take very little actually bring that to Zambia and set it up. We normally as well have an overseas trip for the winners, and it's a research trip. It's definitely not a holiday. It's to go and engage with the community and find out more, research more about their project, find out if it's suitable for them, ways they can improve it, because the famous word innovation, it's a two-way process. We can have great ideas, bring it somewhere, and someone can say, we have a different way of doing it, we have a better way of doing it. So it's about listening to the locals, find out what they want, how they would do it, and improving the design. Given the uncertainties at the moment, we're not sure if that will happen this year. Hopefully it'll happen next year, but it's just uncertain around timing at the moment. So we'll definitely engage with the winners though, and find a suitable way forward with that. things are changing very quickly. So hopefully we'll sort something out. So well done to everyone.
So well done, guys.
And if you don't mind, I'll just take a picture here for. We're normally in an event somewhere, but not this year. Well done.
So, do any of the other judges want to say a few words or comments or on overall?
Yeah, I think just very quickly, thanks a million, guys, for the participation. This thing, I mean, with presenting stuff, it's always difficult to get up in front of a crowd, but doing it down through a laptop gives its own complication as well, you know. So thanks for the quality of the presentations were excellent. And that really makes it almost more difficult for us doing the judging. Just a quick one on Flyco. I mean, I think he got scuppered a small bit by COVID. I think he probably would have been a small bit further down the line, but I think there's a relatively clear path towards its implementation. And then with regard to Q and Sinead's project as well, I think there's almost scope there to almost join forces. I think they were unique enough, and I thought like the concepts are pretty sound. So probably just there's probably a room there almost to collaborate on something. But yeah, no, there's definitely quite a bit to develop on that. Relatively easy anyway. So well done, guys. Well done for the presentations and so forth. And we'll be seeing you again.
Thanks very much.
Sometime in person, yeah. Are there any questions there, guys, from any of the winners? Anything you'd like to ask any of the panel, or obviously EWB here about it before we move on?
I don't think I have any questions. I just like to say thanks very much for judging the competition and for doing the work that you do and giving us this opportunity to come up with all these great projects.
Yeah, thanks a million.
Yeah. Thank you very much. It was a really enjoyable experience and loads learned, you know. So yeah, it was brilliant. Thank you.
And thank you guys for taking part. And yeah, no, we're really delighted we could go ahead with it this year. And as I saw, Elaine, who's actually one of our EWB directors there, said in the chat, you seem to have all done extremely well in very challenging conditions, and you've all progressed with the products and came to this point. So huge congrats on that. So.
Okay, guys, normally we would offer you some food and maybe even something a bit stronger. But you're on your own this year, unfortunately. No doubt.
Go get Deliveroo there. No, yeah. Celebrating stuff.
We didn't think about that, Emma. We should have done.
Yeah, no, I know. Yeah.
But no, just to wrap it up and say huge thanks, first of all, to everyone who participated, because I know during the year, having visited the colleges and done different workshops with you guys, it's a process, and it's a hard process. So well done to all. Well done to the winners. Also, Flyco, really innovative project. I think it's got a lot of potential. I also think Q and Science Cubes also have potential, particularly within the Zambian context. So interested to work together with you guys and see how we can, or where we can bring that. And huge thank you to all the judges who are probably getting extremely hungry as we've kept them past their lunch. But really thanks for your time and input from here and overseas, Bryn, although overseas doesn't mean the same as it did anymore in this virtual world. But just to say thanks to everyone and well done to all the projects, because I think just a final thought, really within this current climate with lots of emergencies, we really need people who think differently and are innovative. Innovation is a word overused, but I think all the projects today and all your thought process are really going to stand you in good stead. So hopefully you'll engage with EWB and our different networks again, and we look forward to working together with the winners. So well done to all, congrats, and thanks for the morning.
Thanks very much.
Thanks very much. Thanks, guys.
Yeah,
yes.
thanks, guys.
Yeah, let's do
Thanks,
it.
everyone.
Virtual clap. Well done, guys. Excellent. Okay, well, yeah, if there's no final comments, then we'll wrap up there. So yeah, just huge thanks again, everyone, and well done. And obviously, as Declan said, we'll be keeping in touch about next steps with all the winners. So yeah, talk to you again soon, and yeah, celebrate, enjoy lunch now. Yeah, treat yourselves, especially.
Black fly burgers. It's going to be great.
Yeah, I saw someone saying flies for lunch there from Robert. So yeah, exactly. That's on the menu soon. Cool. Cheers, guys. Have a good weekend.
Thank you very much.
Bye, guys. Bye.
Bye. Bye.